Good morning, everyone, and thank you for joining us for Continuous Loading with Snowpipe. My name is Perez. I'm the Director of Product Marketing at Snowflake Computing. Joining me today, we'll have Torsten, the Director of Product Management, who led the development of Snowpipe for Snowflake. So we're very excited about this webinar. This feature has been something that customers have been requesting for, essentially since the beginning, the GA of Snowflake initially. We've had people come to us and say, we have data that's being generated continuously, and it'd be great if there was an easy, affordable, kind of lightweight way to be getting their data into Snowflake. So we're excited to talk to you a little bit about how that's going to work. Now, the need for up-to-date data is something that I think everyone on this webinar has already is very familiar with, right? So it doesn't matter if you're a data analyst or you're a data scientist or you're on the executive team. There's a driver that's pushing you towards the need for continuous data and really up-to-date data that's in your database at any given time. You want to know whenever you're querying data, transforming it, accessing it in any way, that the data that's in there represents the most up-to-date data that you have that you could be using in your analysis. And unfortunately, having stale data, it can be even worse because it can be much worse because you'll be dealing with, you'll be making inaccurate conclusions, you'll have skewed statistics, and really be making misinformed strategy that will kind of affect you down the line. So continuous data is a very useful thing to have for anyone, regardless of role. Now, we know that data is being generated much faster than ever. It used to be that corporate data would be updated infrequently, either daily or weekly or even monthly. You'd be adding this data into your data warehouse. But now we have web data, app data, mobile data, sensor data that's generating this constant flow of analytically useful data, but data that is can really be a challenge to get into Snowflake and to other data warehouses because it's being generated so quickly. It's being generated in multitude of very small files, and that really leads to some problems. Now, the traditional way of dealing with loading data into a data warehouse, looked a little bit like this. You'd have data that's being generated continuously, and you'd load it into a staging environment like S3, and then you'd batch load that maybe on a daily or hourly basis into your database, whether that's Snowflake or anything else. Now, unfortunately, because of this methodology of batching things, daily, hourly, even every 30 minutes, the data in the database is going to end up being stale. And if not stale, then certainly not as available as the data is being generated. So it's certainly something that we've had people request. We need to be able to analyze our data as it's coming in, as it's being continuously generated, or at least very close to the time when it's being generated, so that we can, continue to work with that data as quickly as possible and make the important decisions that are being driven by the data that's being generated. So with that, I will pass it over to Torsten. He can describe a little bit about what they've built with Snowpipe and how you guys can utilize it to load your continuous data.
Thank you, Ross. So let me see if I can advance the slide here. So essentially, if you think about the various different ways how you can load data into Snowflake, the one that you are probably aware of is the copy command, which was designed for batch loading scenarios where, as Ross pointed out, you accumulate data over a period of time, hours or days, and then you would launch a copy statement to load the data into your target tables in Snowflake. You can work around some of the latency-related issues for continuous data by following a micro-batching approach, again using copy, where you accumulate the data over smaller periods of time, for instance, a couple of minutes, and then use a copy statement on a schedule to load it. But it's not really a continuous way. because the data loading is not triggered by the arrival of the data itself. It's driven by a schedule. So with a continuous loading approach like Snowpipe, what you would want to do is have a data-driven way how new data arrives in Snowflake in your target tables. And with Snowpipe, we are essentially offering you two different options. I'll explain them in the following slides in a little bit more detail. But at a very high level, the first option is that you point a Snowpipe to a bucket in AWS S3, and you define event notifications on your S3 bucket, and then let these event notifications, let them being sent to a Snowflake. And as soon as new files are landing in that S3 bucket, those files are then automatically picked up by Snowpipe and loaded into your target tables. That's the first option, and I'll show that in the demo. It's a completely configuration-based experience. And in contrast to the second option, which gives you more control and more flexibility. So in this case, you would still stage your files in an S3 bucket, but then you would invoke the actual loading through a call into a REST API that Snowpipe provides. And you can write your applications against the REST API itself. We're also providing Java and Python SDKs that make it a little bit easier. Option 2 is available today for customers that are running Snowflake in the US West region. And option 1 we are going to launch in a couple of weeks in January. So let me tell you a little bit more about the scenarios here that are driving this experience. So what we see very, very often is data sources providing their continuous data feeds into services like, for instance, Kafka or Kinesis. And you can use them to stage your files into an external stage, a bucket in S3. And then as soon as these files arrive in the bucket, you send a notification from S3 to Snowpipe. And then as soon as Snowpipe receives that notification, it places the information about the new file in a queue. And then Snowpipe runs a serverless experience for you where asynchronously behind the scenes, Snowpipe loads the files from S3 and places the data in your target tables. What you're seeing here on this slide is essentially an illustration of option 1, where you rely on S3 notifications, send them into an SQS queue, and from the SQS queue, Snowpipe picks up the new files and goes through the loading process. The following slide shows you an illustration of the current preview with the REST calls. So on the left-hand side, you see your application. This can be an actual application that you're running somewhere, for instance, on a virtual machine, but it could also be code that you're running in an AWS Lambda function. And that Lambda function or application then takes care of placing the load files in the S3 bucket. As soon as the files are persisted there, you would invoke the REST API for Snowpipe from your application or your Lambda function. Snowpipe then places, as I mentioned, these files in a queue just right behind the REST endpoint, and then you have the serverless loader that works off of that queue to load the data into the target tables that you have defined. And here's option 1. Essentially, you place a file in your S3 bucket. As soon as that happens with S3 notifications being set up, that notification would go into an SQS queue that Snowpipe provides. And as soon as we receive that notification, we would then start loading the file into your target table. And the typical expectation here is that within about a minute after you've sent us the notification, either through the REST API or through the SQS queue in the case of option 1, you would see the data show up in your target table in about a minute after that notification was placed. Something to keep in mind, as you saw on these previous slides, we are still relying on S3 as the underlying as the underlying staging area for your files. So you still have to render your data as files. It's not directly connecting into Kinesis data streams or into Kafka topics, but you can rely on tools such as Kinesis Firehose or the Kafka S3 connector to persist your load data into S3 files. The other aspect is that Snowpipe does not allow you to control transaction boundaries across a number of statements. So some of you might be using merge in combination with a copy statement to take the data first into a staging table, but then in a second step from the staging table into other target tables. You don't have the ability right now to define transaction boundaries over a number of different statements with Snowpipe to drive multi-step loading pipelines. So those are probably the two most important things to keep in mind. I guess probably a lot of this will become clearer as we go through the actual surface area and the experience. I've put together a little demo using Twitter as an example. And what I would like to show you is essentially having a Twitter feed going through Kinesis Firehose, and S3 bucket, and then configuring Snowpipe with option 1 so that as soon as new files are being placed in the bucket, they're being loaded into a target table in Snowflake. Let me share my screen here. Okay, hopefully you can all see my screen at this point. So here I am in the Snowflake worksheet, and the first couple of steps are the DML that I would use to configure Snowpipe with option 1 for continuous loading. The first step is a familiar command. We are creating an external stage that points to a Snowpipe demo bucket in S3. Let me run this here. The next step then would be to define a target table for Snowpipe. This is a table here called Snow Table. It's a fairly straightforward table. It just has a single variant column, and the idea is that we can place JSON formatted tweets in that table. The next statement that you see down here then is a new statement that we've added to the surface area, and it introduces a new database object, which is called a pipe. And you can see here I'm creating a pipe called Snowpipe with the auto ingest option equaling true, and that essentially means that I want to use option 1 with an automatically configured SQS queue for the loading experience. But the key part of the pipe is what you see down here is essentially wrapping a copy statement. And by wrapping a copy statement into a pipe, you're telling the pipe to run this copy statement continuously. And then as soon as new data arrives on the pipe, as new files arrive on the pipe, then this copy statement expresses the semantics and the transformations that you want to perform for your loading process. So let me create this pipe as well. You can see we successfully created the pipe. You can look at existing pipes by running a show pipe statement. And let me also run the show stages statement, which already exists today. But what you can see here is there's a new column that we added to the show stages command, which is called notification channel. And what the notification channel holds is an SQS ARN. Let me try to copy that over here. So we'll take all of that. And then we'll jump over into the AWS console to configure the notifications for the bucket that sits behind our stage. Before we go there, let me just quickly run this select count star statement over the target table just to show you that currently we have no rows in the target table. So the count is 0 as expected. Now jumping over into the AWS management console, over here you can see I'm in a bucket. It's currently empty. Let me refresh just to show that. So no files in the bucket. Now the next step for us is to take that SQS ARN and put it into an event notification. You can see you can configure event notifications on the properties of a bucket. and then say add notification. Here, let's call it Snowpipe. We are subscribing to the object create events, and we're going to send these notifications to an SQS queue. And here we are using that ARN that I just copied from the show stages command. So this is the experience for configuration that you would go through for option 1. You can use a similar experience for option 2 as well. Instead of sending your notifications to an SQS queue, as in this case, you would just simply pick Lambda as the target for these notifications, and then use a Lambda function in AWS to invoke the REST API. And that would get you to a very similar experience today with option 2. So let's save this event configuration. And then the next step for me is to go into Kinesis, and let's start with creating a Kinesis data stream where we want to place all our tweets as they come off of the Twitter APIs. Let's call this the Twitter stream and create that stream. Take a look at it. And while that is creating, we can connect this stream to a fire hose. Let's call this delivery stream Twitter to S3. And to get this input from our Twitter data stream, no transformations. Target should be our S3 bucket. This is the bucket that we have defined as our stage for Snowpipe. Here, let's configure our buffer to be a little bit more aggressive. So 1 megabyte or 60 seconds. Now let's use this IAM role. There's the button that I'm looking for. Whoa. Let's try this. And hit next. And create the delivery stream as well. So this stream should also be up and running. Active. Now we just need a data producer that feeds that stream. So here, I have a little Python program that subscribes to the Twitter sample APIs. And as I start this, you can see there are little dots flying by. Each of these dots represents a tweet. And you can see we're at about 400 tweets right now. These tweets are being sent to this Kinesis stream that we're just looking at here right now. And let's take a quick look into the monitoring experience here. We're not yet seeing the traffic. Do the same over here. All right. Let's take a look at our bucket. Yes, and if I refresh the bucket, you can see that there was a folder or a prefix created over here. As we look at it, you can see that the first files with tweets are landing in the bucket. And if you take a look at the timestamps, you can also see that they're about a minute old. And every couple of seconds, a new file is arriving in the bucket. So at this point, our data delivery pipeline into the bucket that underlies our Snowpipe pipe definition, that seems to be working just fine. Let me jump back into the Snowflake worksheet over here, and let's give this count statement another try. And you can see at this point already we have loaded 2,200 tweets into our target table. And let's take a quick look at some of the tweets over here. Run a quick select star statement. And you can see this is the information that we're getting from the Twitter APIs. And you can see the familiar fields. A field that I'll be using in just a minute is the language field that you see here, which encodes the language that's being used for the tweet. And let me just run the count statement again. And now you can see that we are almost 3,400 tweets already. So you can see the data is continuously flowing already into our target table through Snowpipe. So something that you would typically do with a continuous data loading pipeline like this one is to run a little bit more expressive queries. And what you typically also do is then express conditions over time. So here's a little bit more interesting query. I'll run it for you and then explain a little bit more what the query does. So here, this query essentially breaks our tweets that are going into my target table, breaks them into 1 minute sized time windows. And you can see I have 3 minutes already in the table. And then what it does a count of all those tweets that are tagged as Spanish language tweets. So here in the where clause, you can see is the filter expression that I'm using to check for tweets that are in Spanish. What would happen if I rerun this statement, you can see at this point already we have the next window that just opened up. So here we have 4 time windows. The 4th minute is live. And as you rerun that statement, you will see that the count in that time window, the last minute, is increasing as well. So that might be a more typical example of the kind of queries that you run over a continuous data feed, for instance, to track trends over time as they evolve and as new data comes in. So that essentially gives you an impression of Snowpipe in action with option 1, which is the easiest one coming out in January. You can build a very similar experience using the current option 2 version of the preview, also using S3 notifications and then Lambda. And what you saw as well is how you would integrate with typical continuous data providers such as Kinesis or Kinesis Firehose. With that, let me jump back into the presentation and hand it over back to Ross.
Great, thanks, Torsten. So, as you saw, this is going to really enable, once you have Snowpipe set up, it's going to enable a significantly easier process for automatically, loading data in a continuous fashion. So, you'll have your data available in seconds. You can avoid the repeated manual copy commands that you may be currently using. Of course, this works with the structured and the semi-structured data that you need. And then we're going to talk. We're going to talk a little bit about pricing here and how it works. And I already see some questions coming in on exactly how this works. But the upshot is, and the benefit is, that you only have to pay for the compute time that you're using to load data, and that's the compute time in the Snowpipe service. So you're still essentially using Snowflake data warehouses, but they are a shared service within the Snowpipe experience. And so you'll end up paying for a significantly smaller amount of warehouse time because we're basically using the infrastructure in a much more efficient way across multiple customers. So in addition to that, there's also no management, so you're not having to worry about kind of cleaning up the data as you're loading it. You can take in pretty much any data that you'll be sending to us, and of course, it's a serverless service, so you don't have to worry about spinning up servers or altering the size of the warehouse depending on the types of data that you're loading. So the pricing is it's kind of interesting because it's actually so simple that in some ways it can sound complex. But the benefit is here in the old way, right? You would have to go create a warehouse that would probably have to be running all of the time if you have continuous data. And you'd use that warehouse to load your data, and at times, of course, it would be that your warehouse would probably be running significantly more capacity than you actually needed. Now with Snowpipe, you're essentially being charged for the compute capacity that you're using, so in credits, but not at the warehouse level. So you're paying a significantly reduced amount to be able to load this continuously generated data. And you'll see this as a new line item on your Snowflake bill. So Torsten, would you mind kind of going into a little bit more detail on specifically how that warehouse time is computed and those credits are computed for customers?
Yeah, happy to. So as Ross mentioned, it's a serverless experience for you as a customer. What we are doing is we are tracking the load that you are placing on our internal servers that are backing up Snowpipe, and we are tracking that at a very fine grain. So we are tracking it per core and per second, whatever cores and seconds you have kept Snowpipe busy with the load files that you have sent to us, we are aggregating that and then translating that back into Snowflake credits. So you will very likely end up with fractional Snowflake credits if you're using Snowpipe. And if you're not fully utilizing a load warehouse before, then you'll probably also pay less when using Snowpipe because you're not paying for underutilized core. So the fact that we're charging on a per core basis may open up opportunities for cost savings as compared to the micro-batching scenarios with a constantly running warehouse that we talked about at the beginning of this presentation. To keep in mind here, from a billing perspective and pricing perspective, nothing really changes substantially. We would charge you in Snowflake credits, and whatever credit price applies to you and your specific account, that would also then carry forward into the price that you pay for Snowpipe. The way how you track your Snowpipe utilization and cost is, first of all, going into the billing and usage page on the portal, and you see a screenshot of that. So if you go over there, you will find a new virtual warehouse that we're showing there called Snowpipe with a little snowflake sign in front of it, which just illustrates that this is a serverless Snowflake run experience. And then you will get the same breakdown on a daily basis for the usage of Snowpipe. You'll see the number of credits, and if you click on a specific day, you can also see the intraday consumption. In addition to that, we also provide a set of new functions in information schema. For those that want to drill to the next level, you can use those functions to look at individual pipes or individual date ranges to figure out how much Snowpipe credits you used, either for a given pipe that you have created or for a certain specific time period. And so that's really all that I think you should keep in mind. The key takeaways really here are whatever load you're putting on Snowpipe, that's what we're translating back into the Snowpipe credits that you see on the account page. And idle times that you may run into with a more traditional warehouse-based experience, those idle times they go away. You are no longer being charged for capacity that you're not using. Ross, back to you.
Thank you, Torsten. Yeah, great. I think we can step into Q&A here, and wonderfully, we have a great problem is that we have 24 questions already. So I think we'll try to get through them in kind of turbo mode here to try to address as many of these as possible. Question here from Patrick Burkhourt. Can I use an existing loading warehouse? And I assume that he means, So there's two ways to interpret that. First of all, can I continue to use loading warehouses? Absolutely. You can still load data into Snowflake using the put and copy as you have in the past. But if you're using the Snowpipe service, you have to use the Snowpipe service, and you won't be using your warehouses, no, because it's a service. So question here about availability. Torsten, how will this be distributed across regions and to Azure? Will this happen kind of immediately, or is it being delivered into one region first and then other regions later?
Yeah, so we are right now previewing the capability in US West, and we're in the process of rolling it out to other regions as well. We hope to have US East stood up sometime in January, and then we'll take it into the other Snowflake regions after that. And speaking of Azure, yes, this will be available on Azure as well. But first, we need to get our launch in Azure ready in the first place. Yep. But Snowpipe definitely will come to Azure as well.
Yeah, that makes sense. And so here's another question. Does the compute cost for Snowpipe, will it be lesser than the cost using the regular copy into command? And Torsten, I mean, feel free to jump in here, but I would say that what we are attempting to create here is either similar or lesser cost and significantly increased ease of use. Would that be an accurate way of describing what the experience will be like?
Yeah, that's right. And particularly customers that are running a warehouse for loading purposes, and they're running this warehouse continuously. In those cases, it's very easy to end up with an underutilized warehouse, where at least a few of the cores that you have available in that load warehouse are not constantly exercised. So if that's the case for you, then the easiest way to explain it is if you move that workload to Snowpipe, you would no longer pay for any idle capacity. So these idle cores that you had in your load warehouse, they would no longer be an issue with Snowpipe. You wouldn't pay for them anymore.
Thanks for going into that. So somebody said, looks really useful. Why not offer a GUI to obviate the need for hand coding? That frees knowledge workers from programming. More about
that's a great question. Yeah, that's a great question. At this point, we haven't really wrapped our head around what's the simplest way to expose that in the UI. That's definitely worth doing for us. But also, you should keep in mind that the full round trip requires you to leave the UI at least at some point. For instance, to go into your S3 bucket and configure notifications over there. But you're definitely right. At least defining a pipe is something that we should allow through the UI as well.
Good to know. So Snowflake's copy into command has trouble when there are too many files in a given S3 bucket. How will Snowpipe handle that? If all the files keep landing in one bucket, does that affect the load, or is that a limitation on a folder, not a bucket?
So yeah, that's a common problem if you're running essentially list on the S3 bucket behind the scenes, which is something that traditional copy does. Snowpipe is not exposed directly to this problem, simply because Snowpipe acts on individual file names. With the notifications or with the REST calls, you send us individual file names, and because of that, we do not have to run a list command on a bucket when you use Snowpipe for data loading. So that avoids a big part of the problem. But still, I would encourage people to use a meaningful number of files in a bucket, and if that doesn't really work, then think about using prefixes to structure the space of files in your bucket a little bit more.
Great. I'm just sifting through the questions here, trying to find the ones that would probably be most interesting to the most people. So here's a good one, I think. So is the automatic load simply a copy into, or can it also include a merge statement? And I think we could, kind of increase the scope of that to say, what else can I do besides copy into as I'm loading my data in?
Yeah, that's really a fantastic question. So at this point, Snowpipe only supports copy, and whatever you can do functionally with a regular copy statement and doing that in a continuous fashion. We are totally aware of the fact that a lot of customers need to do more with their data than just copying it into a staging table inside Snowflake. Merge is a common example. Running insert, update, delete statements is another one. That is the next step that we're looking at to extend Snowpipe in the next couple of months. And we have started design discussions around this problem here at Snowflake. But at this point, you probably still need to, if that's the use case that you see, you probably still need to run, let's say, merge or your DML statements on a schedule basis. And then as soon as we have the next step of the continuous loading pipeline in place, then we can also then offer you to run, for instance, merge in a similar continuous way. Also, something that I saw in the list of questions here that I really want to jump on really quick is the question just says, does this require an AWS account? And not necessarily. So the Snowpipe experience also works over internal stages. So those are stages where you place files with a put command, for instance, to the JDBC driver in essentially a managed storage that Snowflake provides for you. And you can use that as well for Snowpipe. So you can place files in an internal stage with put and then send us a notification through the REST API.
And so how about errors? So this is a good question. How does someone know that all of the files have been ingested correctly?
Yeah, great question. So on the REST API, we provide a function that's called getHistory, which allows you to pull the essentially the status of the pipe that you're sending this to, and that will give you a breakdown of the files that have been loaded successfully. We'll also show you the files where we have run into trouble, and we'll give you the actual errors that we have seen when we tried to load the file. So that's one side of the picture, essentially. How do you get status or error information on the REST API? You can also access similar information through the load history of the target table of your pipe. If you pull the load history for your target table, we'll list you the various different files that have been loaded successfully, but you'll also see files where, again, we have run into any issues or that we couldn't completely load. So those are essentially the two places that you can go to find status information, to look at exceptions. One is on the REST API, and the other one is on the SQL side.
Yeah, so I saw two related questions that I'm going to kind of ask together. So first of all, are there any file size limits? And second of all, what amount of data, or you could even think of this in terms of what number of files, what size of files, makes Snowpipe more attractive, and maybe what makes it less attractive to use? Well, in terms of file sizes, I would think of these continuous loading scenarios as scenarios where file sizes tend to be a little bit smaller, and that's totally okay. I still would encourage people to have files that are at least a few megabytes large in size. As long as you're not going above, let's say, 100 megabytes in file size, then you will also find yourself in a place where it's quite likely that you see your files load within a minute after you've sent us the notification. Overall, there are no limits on the file size itself, other than what you would have with regular copy or your S3 bucket. But obviously, the larger the file, the longer it takes for the file to be loaded completely. That's the thing to keep in mind. Right, that makes sense. So Torsten, I think we're kind of getting to the end of our time here, but I'm not sure if you see any other questions in here that you feel would be best to address with the entire team here, with everybody that's on the webinar. What do you think?
Well, the other one that I see here, which is interesting, is direct integration with Kinesis and Kafka. At this point, what I would recommend people to do if they're using Kinesis or Kafka is to either use the Kafka S3 connector to send the data into an S3 bucket, or on the Kinesis side, use Kinesis Firehouse to do that. And I'd love to hear more from people then if that is not good enough. And I'd love to better understand what the reasons are why we need to have a deeper integration into either Kinesis data streams or Kafka topics.
Excellent, thanks. So we have we answered all those questions, Torsten, but there's still about 24, 25 questions left to be answered. So we see your questions. We will get back to you personally as we go along here, and please do feel free to reach out to us. Torsten, if someone wants to kind of talk about Snowpipe and learn more, what are some good ways for them to do that, either on the web or reaching out to you personally?
Yeah, definitely. Feel free to reach out to me. Happy to answer additional questions or help you get started.
Great. And then also, there is documentation for this, correct, on the documentation site?
Absolutely.
So
yes.
if you have questions about, I've seen a lot of questions about, how do I set this up? How do I configure this? How do I work with that? The documentation is really the best place to get started with that. So we're very happy to have had all of you on, and we're very happy that there's so much interest about Snowpipe. And Torsten is working hard with our engineering team to continue to develop this feature into something even more exciting than what it already is. So we will certainly look forward to the future there and keep you all appraised of any updates to the feature as we go along. So Torsten, thanks for your work on this feature and for joining us on the webinar.
No problem. Thank you.